we already know that glycerol gets into metabolism by going through a two-step process to become dihydroxyacetone phosphate. It's a redox reaction. One of them is a redox reaction, and you are producing an NADH in one of those steps. Don't worry about the details. Just know that it's a two-step process, and you get that DHAP, which then goes right into glycolysis. Now, for the fatty acids, remember we said in the previous video, they get activated using two high energy bonds. So we count that as two ATPs input in order to do this. And then it gets shuttled, transported using a molecule called carnitine from the cytosol into the matrix of the mitochondria. So now we have an acyl-CoA in the matrix of the mitochondria, and we're going through a process called beta-oxidation. These are 4 steps. 2 of the steps are redox reactions, and one of the steps produces an FADH2, and the other one produces an NADH. Why do we care? Because remember, those are the ones that are going to go to the electron transport chain to produce all those ATPs. Okay, so my 18 carbon hypothetical acyl-CoA is going to go through these 4 steps. It's going to go through a redox reaction where you produce 1 FADH2. This is in the matrix of the mitochondria. Then there's going to be a hydration reaction. And then the third reaction is another redox, a dehydrogenation. We're removing hydrogen and we're going to be producing 1 NADH. Okay? And then the last reaction is something called lysis. So lysis means you're breaking a bond, breaking something. So imagine that you've got all these carbons. Okay, so it's an 18 carbon fatty acid, long chain. And we've got this over here. So this is the acyl-CoA. When you're going through these 4 steps, the last step cuts this off, and then this gets turned into the new acyl-CoA. So this hypothetical thing has 1, 2, 3, 4, 5, 6. Let's pretend it's got 6 carbons, okay? So in one cycle of this beta oxidation, at the end, you chop off 2 carbons. You form, that's your acetyl-CoA is a 2-carbon CoA. And the rest of this is the acyl-CoA. You then go through another cycle and you chop off 2 more. You don't need to go through another 3rd cycle because now you've created 2 CoAs. So the point of all of this is to end up turning that long chain fatty acid into a bunch of acetyl-CoAs. So think about this. If you have an 18 carbon fatty acid, how many acetyl-CoAs can you get out of that? Well, 2, 2, 2, 2, you're going to end up producing 9 acetyl-CoAs. Make sense? And where do those 9 acetyl-CoAs go? They go into the Krebs cycle. Each one of them going through one loop, and then the next one goes in. Each one of the acetyl-CoAs condenses, reacts with oxaloacetate to produce citrate, and then goes through the cycle. And then the next acetyl-CoA comes in, condenses with oxaloacetate and produces citrate and goes through the cycle. So the 18 carbon fatty acid produces 9 acetyl-CoAs. How many beta oxidation cycles does this 18 carbon fatty acid have to go through? Remember, each cycle chops off 2 carbons. 2 carbons, 2 carbons, 2 carbons. Your instinct is to say, okay, goes through it 9 times to get the 9 acetyl-CoAs. But that's not correct. It only will have to go through it 8 times because that last time, when you have 4 carbons left, and you chop 2 off, this Acyl-CoA is an acetyl-CoA. So it's always -1. So even though you have 9 acetyl-CoAs, you have to go through the beta-oxidation cycle 8 times. Okay, so if it was a 16 carbon fatty acid, like for example palmitic acid, how many acetyl-CoAs you get? You get 8 acetyl-CoAs. But how many cycles do you have to go through? Only 7, because the last cycle, when it's a 4 carbon, you chop it in half, you end up with 2 acetyl-CoAs. Hope that makes sense. Okay, so now let's crunch the numbers. Each acetyl-CoA, if you remember from our biochemical energetics lectures, each acetyl-CoA that goes into the Krebs cycle is going to ultimately be producing a total of 10 ATPs, if you remember. Remember, the Krebs cycle gives you 3 NADHs, 1 FADH2, and 1 GTP that becomes ATP. Do you guys remember that? And remember that the NADHs go to the electron transport chain, and you get, for each NADH, you get 2.5 ATP. The FADH2 goes to the electron transport chain, and for each FADH2, you get 1.5 ATP. So you add all that up together, you end up with 10 ATPs total, okay, for each acetyl-CoA. Now, in this 18 carbon fatty acid, you're producing 9 of them. 9 times 10, that's 90 ATP. We're not done. Remember, beta oxidation. Each beta oxidation, remember what we said? We produced 1 NADH and 1 FADH2. So each cycle of beta oxidation, you're producing 1 NADH, 1 FADH2. How many times are we going to go through this? Well, if you have an 18 carbon fatty acid and you've produced 9 acetyl-CoAs, you will have gone through the cycle 8 times. So that means you've produced 8 NADHs and 8 FADH2s. So, okay, so what are we multiplying by? Well, these 8 NADHs are going to be multiplied by 2.5, because remember, NADH is going to go to the electron transport chain, deposit its hydrogens onto those big complexes. Hydrogens, electrons get transported, hydrogens get pumped. Remember all that from biochemical energetics. So we have to do the math. And we've got 8 times 5 is 40. 8 times 2 is 16. So that's 20 ATPs. Okay. The FADH2s, what do we multiply it by? 1.5. So we're going to multiply this by 1.5. All right, 8 times 5, 40. 8 times 1, okay, that's 12. Now let's add them up. 32 ATPs. All right, so 32 ATPs, 90 ATPs, we add them together. That's a total. From this one fatty acid, you can get 122 ATPs. But we're not done. Remember how we had to activate the acyl group? We had to activate the fatty acid. Remember how we had an ATP and we broke 2 high energy bonds to produce adenosine monophosphate and 2 inorganic phosphates? Okay, so that activation counts as 2 ATPs that we had to put into the system. So we got to subtract 2. So out of this 18 carbon fatty acid, you can produce 120 ATPs. Remember how we did all of this with 1 glucose molecule? 1 glucose molecule could give you a total of 30 ATPs through all of this stuff. Well, 1 fatty acid that's 18 carbons can give you 120 ATPs. So it depends on how many carbons are in the fatty acid. You should hopefully be able to figure it out depending on what fatty acids you have. Okay, and remember, each triacylglycerol has 3 fatty acids. So again, it depends on what the fatty acids are in the triacylglycerol. So that's why you know that you get a lot more energy out of a gram of fat than you do out of a gram of carbohydrate. Okay, good. The last thing we're going to cover in this section in the next video will be ketone bodies. You've all heard of ketosis and ketoacidosis. We'll talk about that. And then we'll end this section of lipid metabolism with lipid biosynthesis, how your body can synthesize fatty acids. All right.